Hello everyone, so we are back to revise acids and bases, which is chapter 8 of your textbook. But at the same time, while revising acids and bases, if you notice the questions in your exam papers or your 10-year series, they are always asking you to write the equations for acid reactions. Therefore, when you are revising acids and bases, the reactions, please also revise how to write the chemical equations and balance them. So as part of today's revision, we will be revising acids and bases and formula and equations at the same time. So that's 2 chapters. That's actually 1 whole term's worth of work. So I hope you listen intensely, you focus on the lesson itself, and at the same time, I will be pausing the recording from time to time in order to get answers from you, be it answers to the questions or your balanced chemical equations. All right, so let's dive into it. First, we have learned acids. Now, acids are a very important class, a very important group of chemical substances. There are many acids found around us, be it in the food that we eat, be it in the chemicals that we use in industry to make various other products. And that's why acids are a very important class of chemicals that all students will have to study as part of chemistry. So what do we know about acid? Number one, you need to know that all acids, they produce H plus ions. Okay, so all acids share this common characteristic. They produce H plus ions. So the H plus ion is the ion responsible for acidic properties. Okay, now they produce these H plus ions when they are dissolved in water. So it is very important for acids to have the state symbol aqueous. Aqueous means it's soluble in water. It dissolves in water. So the common acids we have, the first one, hydrochloric acid. HCl is the formula for hydrochloric acid. Remember, the state symbol has to be aqueous because it only produces H plus ions when dissolved in water. So from the formula HCl, you can tell that it's going to form H plus and Cl minus, which is called chloride. That's why for HCl, the salt produced is the chloride. So this we have done as part of the term 3 WA. We have also done it in our lessons in term 3. So HCl produces the chloride. Other common acids, HNO3. Nitric acid is HNO3. From the formula, again, you can see it will form H plus NO3 minus. NO3 minus is called nitrate. Hence, HNO3 is the acid that produces nitrates. Finally, H2SO4, sulfuric acid. Sulfuric acid also forms H plus like other acids would, but because of the 2, sulfuric acid will produce double the amount of H plus. So it forms 2H plus, which is double the amount of H plus, as well as SO4 2 minus. SO4 2 minus, you should know, is the sulfate ion. Hence, sulfuric acid produces sulfate as a product. So these are the common acids that you must know. You have to know the formula. You also have to know which ions it will form, because this will guide you to naming the salts that is formed later on. Okay, so let me just pause the recording here for a short while. We have just covered what ions are present in acids when they are dissolved in water. So now let's move on to the physical properties of acids. Now, physical properties refers to things that you can observe with your 5 senses. So for example, the first physical property has to do with taste. So sense of taste will tell you that acids taste sour. That's why acids are commonly found in fruits which are sour, such as lemons, lime, apples, grapes. They all contain different acids. In addition, common acids that you add to your food include vinegar. Vinegar contains an acid. Vinegar tastes sour. Now, the next physical property has to do with sense of sight. You look at the color. Now, acids on their own have no color. You have to add an indicator to acids in order to determine that it's acidic. So, for example, a common indicator is to use litmus paper. In this case, we will use moist blue litmus paper, and they turn moist blue litmus paper red. So this is a common property, a common test to determine that something is acidic. Besides litmus paper, we could have used universal indicator. So acids will turn universal indicator. Depending on their pH, they could be red, orange, or yellow. So this is the complication. You need to know that universal indicator gives you the approximate pH depending on the color. So red is pH 1 to 2. All right. Orange, you are looking at pH values of 3 to 4. Finally, yellow is about 5 to 6. So you do need to know the rough pH ranges and the colors with universal indicator. Okay, so using litmus paper and using universal indicator is a good way to determine if something is acidic. Now, besides that, the next physical property, acids have a pH value less than 7. And finally, the last physical property has to do with conducting electricity. Now, talking about conducting electricity, all right, acids, they do not conduct when they are gaseous. So if it's gaseous, it won't conduct electricity. Remember, for acids, the state symbol is always aqueous because you have to dissolve in water to produce H+ ions. So acids conduct electricity only when dissolved in water. Okay, so remember, dissolve in water means the state symbol is aqueous. All right, so these are the 5 physical properties of an acid. Maybe I can zoom out and we can take it down quickly. Okay, so now let's move on to the chemical reactions of acids. As you may remember, there are a total of 3 different reactions of acids, meaning acids can react with this, that, and that. So 3 different reactions that we will learn. All right, so let's start with the first reaction, acid plus metal. All right, so acid plus metal forms a salt and hydrogen gas. Okay, so whenever a gas is formed, it is important to know the test for the gas. So for instance, how would you test for hydrogen gas? So in this case, we have gone through this in class. The test for hydrogen gas, let's take it down once more, is to insert a lighted splint into the test tube or boiling tube where the reaction is taking place. Okay, and the observation for this hydrogen gas test is the lighted splint extinguishes with a pop sound. Okay, so that is the test for hydrogen. Okay. Now, so you notice that hydrogen gas is formed when you had started with an acid, of course, and a metal. So metals form hydrogen gas. Now, this is an important link to make in your head. Metals typically form hydrogen gas. When they are reacted with acid, they form hydrogen. When they are reacted with water, they also form hydrogen. When they are reacted with steam, they also form hydrogen gas. That's why hydrogen gas is the gas that is associated with metals. So for instance, I've written 4 equations there. You can see I've reacted an acid like HCl reacts with magnesium, metal. So you notice that for a metal, if you're just starting as a metal, it's an element on its own. If it's a metallic element on its own, there is no charge at the start. So it's just Mg, it's just Ca, it's just Zn, because these are metals, metallic elements at the start. They are not combined yet, so they have no charge. So let's revise how do we write an equation. Let's use the first equation as an example. So we have HCl, which is hydrochloric acid, plus Mg, which is magnesium metal.
Magnesium chloride plus
So
H2.
magnesium chloride is formed. So for magnesium chloride to be formed, we now need to write the formula correctly. All right. So we need to look at the periodic table. That's why you need to have a periodic table now. If you look for magnesium in the periodic table, you find that it's in group number 2. All right. So we have magnesium chloride formed. Magnesium is in group 2. If magnesium is in group 2, this means that it forms Mg2 plus ions, because group 2 elements will lose 2 electrons to form Mg2 plus. On the other hand, chloride is Cl minus. Okay, you can remember it as Cl minus because chlorine is in group 17. It gains 1 electron, therefore Cl minus. It is very important to do this working, even though this working is not supposed to be written in the answers. Your answers should not have 2 plus and minus. Your answers should not have any plus and minus charge in them. But it's important to do this working so that you write the correct formula. The correct formula is MgCl2, because you will need 2 Cl minus in order to balance out 1 Mg2 plus. And it's also very important to realize that hydrogen gas is H2. It's not H, it's H2. Okay, because hydrogen exists as H2 molecules. Okay, 2 hydrogen atoms share electron to form H2. So these are things that you must commit to memory and apply accordingly. Do not rush to write the formula. Do not assume that it will just be 1 magnesium, 1 chlorine, because it is important to get the formula MgCl2 correct. Because if the formula is not correct, the entire equation is equivalent to wrong. Okay, so now that you have written MgCl2 correctly, the next step is to balance the equation. What does it mean to balance the equation? Number 1, you have balanced the charges. The 2 plus and the 1 minus are balanced. MgCl2. To balance the charge, we put the 2 at the bottom. Now we need to balance the number of each atom. So you notice that I have 1 Cl on the left, I have 2 Cl on the right, and therefore we need to balance the number of Cl. To balance the number of Cl, we will add 2, but this time round, the 2, to balance out the number, the 2 is added in front of the HCl. So it's 2HCl plus Mg becomes MgCl2 plus H2. So you need to know as well, when do you put the numbers and where do you put the numbers? You put numbers at the bottom is when you are balancing the plus and the minus. The number in front is to balance the number of atoms. Okay, in this case, need to balance out the number of chlorines on both sides. Okay, so your final equation looks like this. So now I have written a total of 3 other equations. You notice for the last one, I've given you the products on the right-hand side. So you need to work backwards. What is the reactant on the left? So for the next 3 equations, can I please encourage you to do it on your own? And once you are done doing it, you can send me your answers so that I can mark your answers as well. Just a note, for zinc, I hope you remember that zinc also forms Zn2 plus ions. So zinc ions are Zn2 plus. Okay, so now let's pause the recording here. For those watching the video, pause the video and let's do the 3 equations. All right. Okay, so we have done the equations. I hope you have had a chance to try. For those watching the video on YouTube right now, okay, so you can actually ensure that you get the equations correct. So I'm going to leave it here for a few seconds, okay, for you to take down the correct equations that are balanced. Okay, now before we move on to the next reaction, let's remind ourselves, acid plus metal forms salt and hydrogen gas. We need to know how to test for hydrogen. We also need to be able to name the salt as well as to write the equation for the reaction. Okay? So every single time you learn a reaction, always learn the test for the gas, how to name the products and reactants, and finally, learn how to balance the equation. And moving on, Before we move on to the next reaction, let's think, do all metals react with acid? Now that you have learned chapter 12, you have learned that metals are not the same in reactivity. Some metals are ultra super duper reactive. Some metals are very unreactive. So there are indeed some metals that do not react with acids. For instance, the metals which do not react with acids include copper, silver, gold. So these are the three metals that are commonly in your syllabus which do not react with acid. This means that if I put copper into hydrochloric acid, there is no reaction. If I put gold into nitric acid, there is no reaction. There will not be effervescence or bubbles. There will not be any gas formed because there's no reaction. Okay, so how do you remember that copper, silver, and gold do not react with acids? Well, this can be deduced from their position in the reactivity series. Because the position of the metal in the reactivity series will tell you whether it's reactive or not reactive. For the metals like copper, silver, gold, they do not react with acids because they are below hydrogen in the reactivity series. So this is how we actually link the reactions of acids to the reactivity series. If I know that the metal doesn't react with acid, I also can conclude that the position is below hydrogen in the reactivity series. Okay, so this is an important link between the chapter on acids and bases as well as the chapter on reactivity series. So the next reaction we'll move on to is, of course, acid plus base. Now, acid plus base forms salt and water. Now, this reaction's name, acid plus base becoming salt and water, the reaction name or type is called neutralization. So now let's look deeper. Acid plus base forms salt and water, right? So acids, you are familiar. You know that it's HCl, HNO3, H2SO4. These are acids. Now, what is a base? A base basically is a metal oxide. So metal plus O, that's a metal oxide, it's a base. Or it can also be hydroxide. So metal plus OH, so like NaOH is a base. Okay, so the moment you see metal with oxide or metal with hydroxide, that's a base. Okay, so over there, I have 4 equations again. So now let's quickly write them. So HCl plus NaOH. So HCl is hydrochloric acid. NaOH is sodium hydroxide. Sodium is a metal. So sodium hydroxide is a base. This forms sodium chloride plus water. Okay, so you must recognize the moment you have oxide or hydroxide, you must form water, H2O, on the right-hand side. Okay. Now the next one, HCl plus magnesium hydroxide. Again, hydroxide. So if it's a hydroxide, automatically on the right-hand side, there's water. Okay. But importantly, the salt form is magnesium chloride. Again, you must think magnesium chloride is not MgCl because it's Mg2 plus, Cl minus. So it's MgCl2. Next step, got to balance the chlorine, so it's 2HCl. Finally, to balance out the OH, I need 2H2O. So the number of OH is equals to the number of H2O. This is an important concept as well in balancing. If you see 2 hydroxides on the left, you will have 2 H2O on the right. This is a pattern that we learned. Okay, and so with that, we have concluded the first 2 equations for acid plus base. This is acid-base neutralization. So now let's practice the next 2 equations. Again, I've given you the next 2 equations. And also, let's try to recall what is the ionic equation for acid plus alkali neutralizations. Okay, so let's do the 2 equations plus the ionic equation that we should memorize. Okay, so now if you look at the screen, you can see the answers for the questions. So importantly, please learn all right, the ionic equation for acid and alkali neutralization, which is the same regardless which acid and which alkali it is. Okay, so please spend some time to take these equations down so that at least when you reread the notes that you have written, you can jog your memory. Okay, you can recap how to balance equations properly. Okay, please don't give up the equations marks. Okay, it may not be easy to write the equations, I understand, but it's doable if you take steps towards writing the correct formula and the correct equation. Okay, now to do with the reverse engineering, meaning if I give you the right hand side and then you work out the left hand side, this is a skill that we need to have. We need to develop this skill, all right, over time. And to develop this skill is not just simply through doing more assessment books or more papers. It is really revising chemistry every day. So test yourself in your head. If I want to make water and sodium sulfate, what should I start with? If it's water, I need to start with acid plus base. Acid is sulfuric acid because it's sulfate. And then to get the sodium, I need to use sodium hydroxide. Okay, so this is a skill that we develop day by day by revising day by day as well. All right. Okay, let's move on to the very last reaction for acids. So we have gone through acid plus metal. We have gone through acid plus base. And the last one should be acid plus carbonate. Now, acid plus carbonate, we are familiar. The word carbonate tells you what gas will be formed. Okay, so if you look at acid plus carbonate now, all right, we have formed salts, carbon dioxide gas, and water. So again, when you learn a reaction, you need to learn the test for the gas, if there's a test for gas. So carbon dioxide gas is tested for by bubbling into lime water. So we bubble the gas into lime water. So when you see lime water, you know, okay, this is testing for carbon dioxide gas. Okay? The observations. This is important. A white precipitate is formed. So if it's carbon dioxide gas, you bubble it into lime water, it forms a white precipitate. Okay? Now, I think this one, you can memorize it. But also important, perhaps more important than memorizing, is to link. Link what? When you read lime water, you need to know the gas is carbon dioxide. Then you must link backwards. Whenever you have carbon dioxide gas, the previous chemical must be a carbonate. Okay? So if you see CO2, before the CO2 must be a carbonate. Only carbonates can form CO2. All right? So now, we again start writing equations. So the first equation over there is HCl plus calcium carbonate. Now, calcium carbonate is CaCO3. Because calcium is group 2, it forms Ca2 plus. Carbonate is CO3, 2 minus. All right, so this is something, again, we have to memorize. The carbonate ion is CO3, 2 minus. So the formula is CaCO3. So now, we have to complete the equation. So HCl plus calcium carbonate forms calcium chloride, CaCl2. All right, so again, we need to know calcium group 2, so it's Ca2 plus. Chlorine group 17, Cl minus. So the formula is CaCl2 plus CO2 plus H2O. Okay, and to balance the equation, again, chlorine 2, so therefore you need 2 HCl. So you start noticing a pattern as well. For many of the group 2 metals, you basically add a 2 in front of the acid to balance it. Okay, for hydrochloric acid and nitric acid. Okay, so now, again, we are going to do the next 2 equations ourselves. Let's give ourselves some time to actually practice writing the equations. Okay, so please finish the equation for the next 2. Okay, they are all acid plus carbonate reactions. Okay, so you should be able to work out what are the products or what are the reactants. So let's complete the next 2 equations now. Okay, so now here are the answers for the equations for the acid plus carbonate reactions. Importantly, again, please don't jump to conclusions. Make sure you write the correct formula. So these are also the 4 ions that you must learn at bottom. You have to learn and memorize the formula of OH minus, which is hydroxide, NO3 minus, which is nitrate, carbonate, CO3 2 minus, finally sulfate, SO4 2 minus. So these are the 4 ions which you have to memorize in order for you to make progress in writing formula and equations. And so with this, we have revised acids and we have revised formula and equations. So with this, we have really hit 2 birds with 1 stone. Okay, so now we will move on to alkalis very, very quickly. Okay, for alkalis, it's going to be much shorter and simpler because now that we have already activated our equation writing mode. So once you are familiar with writing equations, you get into this mode of thinking through, okay, of referring to the periodic table to find the charge. Once you get into the mode, everything becomes a lot more simple. Okay. So now let's move on to alkalis or bases. Now, bases and alkalis are the opposites of acids. Okay, so acids are important chemicals. Bases and alkalis are also important, but they are opposite in properties. So what are bases? Bases are metal oxide. So if you have a metal with oxygen, metal oxides are basic. Okay, they react with acids. Okay, so if you are base, you react with acid. Base don't react with base. Base must react with acid. Okay, opposites react together. Okay, so under bases, we have this category called alkalis. So alkalis are bases, but specifically, alkalis are bases that must dissolve in water. Okay, they are specific bases which dissolve in water, and when they dissolve in water, they form ions. The ion is OH minus, hydroxide. So the hydroxide ion is the ion responsible for basic or alkaline properties. So if they ask you for the ion that makes this alkaline, the ion is OH minus. Now there are 4 common alkalis you must know. We have seen the first one just now. Sodium hydroxide. So sodium hydroxide is actually found in the lab, a very, very, very common alkali. Sodium hydroxide's formula is NaOH because Na is in group 1. So Na plus, then you have OH minus. You also have potassium hydroxide, KOH. So potassium hydroxide, another common alkali. The next common alkali is from group 2. Calcium is group 2. So calcium is Ca2 plus ion. OH minus. So to balance out the plus and minus, I need to put 2 OH minus. Now, calcium hydroxide is an important alkali. It's found in the lab because calcium hydroxide is actually called lime water. So the lime water which you use to test for carbon dioxide gas is actually calcium hydroxide. Now, besides testing for carbon dioxide gas, what else can calcium hydroxide be used for? Calcium hydroxide is added to soil to neutralize the acids. So to neutralize soils which are acidic, you add calcium hydroxide. You can add it either as the solution, the aqueous form, or you could add the solid form. The reason is because if you're adding it to soil, adding the solid is okay because when it rains, the solid will dissolve in the rainwater to form the aqueous calcium hydroxide. And the final alkali, which you all might forget, is this. Aqueous ammonia. Now, aqueous ammonia is an alkali because ammonia can dissolve in water to give OH minus ions. Okay, so long as it can produce OH minus ions when it dissolves in water, it's an alkali. Okay, now aqueous ammonia is sometimes also called ammonium hydroxide. Now, this is less commonly seen in exams nowadays. Most of the time, they will just write aqueous ammonia. So you have to learn the word aqueous ammonia. You have to recognize that NH3 is alkaline. Okay, but if it helps you, you can remember that NH3 is the same as writing NH4OH because when you produce NH4OH, it's when you dissolve it in water. Okay, so these are the properties that you need to know for a start. The ions in alkalis, and you must know the 4 common alkalis in the lab. Okay, so now moving on to the physical properties, it shouldn't be too difficult. You know some of these already. Number 1, alkalis taste bitter and feel soapy to touch. Okay, so alkalis are commonly used to make soaps and detergents. Okay, the next physical property has to do with litmus paper. So alkalis, they will turn moist red litmus paper blue. Universal indicator is another indicator. They turn universal indicator blue or purple. Now this is crucial. All right. Blue is pH 8 to about 11. Purple is about pH 12 to 14. So depending on the pH of the substance, you may have slightly different colors for universal indicator. So universal indicator is a method of determining roughly, approximately, what's the pH. Okay, so far the first 3 physical properties of alkalis should be things that you are very, very familiar with. Of course, the next one has to do with pH value. Alkalis have pH more than 7. And finally, alkalis conduct electricity when dissolved in water, which is why you see that the state symbol is always aqueous. It has to be aqueous because it is only when it's dissolved in water that it has the OH minus ions, which are free to move. Okay, so the 4 common alkalis, aqueous, 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 and the 5 physical properties of alkalis are shown here. So now let's move on to the reactions of bases and alkalis. So there are only 2 reactions. The first one you have seen, acid plus base forms salt and water. This is called neutralization. So remind yourself, the name of the reaction is neutralization. Okay, when you have acid with base. The next one is the one that sometimes we forget. Base plus ammonium salt forms ammonia gas. So it's very important to differentiate between ammonium and ammonia. Ammonium is NH4 with a plus charge. All right. Whereas ammonia is NH3. And you must know how to test for ammonia as well. So ammonia, just now you saw, ammonia is an example of an alkali. If it's an alkali, it's good to basically test with it using litmus paper. So place moist red litmus paper. And usually we do this in a boiling tube or test tube. So we place the litmus paper at the mouth of the test tube. This means that we do not put the litmus paper into the test tube. It's just at the opening, the mouth of the test tube. And the observations, the gas turns moist red litmus paper blue. Okay, and this is possible because ammonia is an alkali. All right. So base, any base like sodium hydroxide, calcium hydroxide, okay, it's a base. So base plus ammonium salt forms salt plus ammonia gas plus water. So now you do an example. So we have sodium hydroxide plus ammonium chloride, right? So what is the salt form? So I know I must get ammonia gas and water. So I can write down first, ammonia gas plus H2O. So what's the salt form? So you got to think, what is left? Sodium is left. I don't see sodium yet on the right. Chloride is left. Therefore, the salt is sodium chloride. So that's actually how you work out what is the salt form. Okay, a good way is actually to write the products that you already know must be formed. So like ammonia gas and water is formed. So what is left? Sodium chloride, sodium chloride. Okay, so these are the chemical reactions of bases, the 2 chemical reactions. First one, acid-base neutralization. The second one, okay, base plus ammonium compound forms salt, ammonia gas, and water. Okay, so these are the 2 reactions of bases or alkalis. Okay, so now let's move on to the last section of today, which is types of oxides. Now, We study oxide because oxides are really common. Oxides are really, really common because your elements are exposed to air, right? So that your metal exposed to air, your carbon exposed to air. What does air contain? Air contains oxygen gas, right? So oxygen gas will react to form oxides. So we can broadly divide them into metal, non-metal. We know elements, they are metals, they are non-metals. So let's zoom in on the metals first. Metals react with oxygen to form metal oxides. Now, most metal oxides are basic. They are basic oxides because they are oxides that react with acids only. Remember, if you are basic, you can only react with acid. Opposites react together. Basic react with acidic. Okay? Now, but there are some specific metals which form amphoteric oxides. The special metals are zinc, aluminium. Now, the last one, of course, is lead. Okay, so we remember it as ZAP, zinc, aluminium, lead. Okay, so zinc oxide, aluminium oxide, lead oxide, they are amphoteric. So why are they amphoteric? The reason why they are amphoteric is because they react with both acids and bases. So amphoteric, the reason why they are amphoteric, why are they amphoteric? Is because they react with both acids and bases. Okay, so you have to remember the three examples. You have to remember the reason why they are amphoteric as well. Okay, so metals, most of them form basic oxides. Basic oxide can only react with acid. That is the majority of metals. But the three special metals, zinc, aluminium, lead, they form amphoteric oxides, which react with both acids and bases. Okay, so that concludes the metals. Either basic, the majority, or three special ones, amphoteric. So now we are done with the metals, we go to the non-metals. So non-metals form acidic or neutral oxides. Again, the majority of non-metals will form acidic oxides. This is where the majority is. So for instance, CO2 is acidic. All right, carbon dioxide is acidic because carbon is a non-metal and non-metals form acidic oxides. If you dissolve CO2 in water, the pH of the solution form will be less than 7. It's acidic. NO2, acidic. Nitrogen is also a non-metal. SO2, acidic, because sulfur is a non-metal. SO3, also acidic, because sulfur is a non-metal. So basically, the majority of non-metals form acidic oxides. Why are they acidic? Because they react with bases only. So we say acid react with base. Acid cannot react with acid. Okay? So CO2 will only react with base. Now, this is the majority of non-metals. The majority of non-metal oxides are acidic. So now we come to the exceptions. So there are very few non-metal oxides which are neutral. And if I write out the formula, you will realize why. Okay, maybe I should write it in a different order so they can see clearly. So one way to remember it is the co-no-ho, right? Carbon monoxide, nitrogen monoxide, and of course, water. These are neutral. So what do you notice? They only have one oxygen, right? They are monoxides. So they are monoxides of non-metals. So if there's only one oxygen bonded to a non-metal, it's neutral. So the co-no-ho, carbon monoxide, nitrogen monoxide, then you have water. So these three are neutral. If they are neutral, they do not react at all. They do not react with acids or bases at all. Okay, so our coal-no-hole, our carbon monoxide, nitrogen monoxide, and finally water, H2O, they are neutral. So they don't react with acids or bases. All right. So this really concludes what we need to know about oxides. So if I zoom out, metals, majority of metals form basic oxides. Zinc, aluminum, lead are the three special metals which form amphoteric oxides. Then we go to non-metal. Non-metal, majority acidic oxides. So like carbon dioxide, sulfur dioxide, acidic. The only exceptions are coal-no-hole, carbon monoxide, nitrogen monoxide, and water, which contain one oxygen only. If they have one oxygen only, they are neutral for the non-metal oxides. Okay, and that really concludes chapter 6 and chapter 8, formula and equations, and acids and bases. So I hope you will also rewatch this video to ensure that you have all the concepts copied out, learned well and understood, and you are able to apply during the exam to the questions. Okay, for more practice, you should really go back to the notes and practice writing the equations once more, as well as learning to write the guest test out once more. All right, thank you so much.